Hello, my name is Ali.
And my name is Deniz. Welcome to our deep dive into nuclear energy's future and technology.
Nuclear energy harnesses nuclear fission. A neutron strikes a heavy nucleus, like uranium-235, splitting it into lighter nuclei. This releases energy. This is evident in Einstein's famous equation E is equal to mc squared. Now this energy powers around 10% of global electricity nowadays. However, with emerging scientific fields in physics, chemistry and engineering, this might change. But Dennis, some people might ask, how does this nuclear energy work?
Well, Ali, I'm glad you asked. Over 400 reactors throughout the world use nuclear energy to work, which is quite substantial. Some are called pressurized water reactors, which look like this, and some are called boiled water reactors, which look like this. These reactors that I mentioned use the element uranium-235, which undergoes fission when its nucleus absorbs a neutron. When uranium goes through fission, it becomes unstable and splits into fragments like krypton-92 and barium-141. The efficiency of this nuclear energy is quite high, but obviously there are some safety risks and hazards we should be careful about. Like, for example, the radioactive cesium-137, which gets quite corrosive and dangerous when upon high temperatures. No, cesium-137 is quite dangerous because of the Chernobyl incident, and it's not to be messed around with.
Future innovations depend on advanced science. Small modular reactors, SMRs, like in the photo above, shrink traditional designs, often below 300 megawatts.
Nuclear fusion, conversely, fuses light nuclei like tritium and deuterium into helium. It releases energy due to the mass converting because of this formula. This requires the overcoming of the Coulomb barrier, which is the electrostatic repulsion between protons, and therefore it needs 150 million degrees Celsius to have enough kinetic energy to collide, which is quite a lot, which is usually the reason why it's done in reactors.
Accident-tolerant fuels, ATFs, enhance fission safety. Traditional zirconium cladding oxidizes above 12,000 degrees.
Fusion emits no carbon dioxide during operation, which makes it a steady, high-output process. Scientists estimate that nuclear could cut global emissions by 25% if scaled up.
However, in this innovation, we will also face many challenges. Many people fear nuclear energy due to its past. So, rebuilding trust through transparency and education is key. Building plants is expensive. However, new funding ideas like public-private partnerships could help.
In conclusion, nuclear energy's future is full of potential. With cutting-edge reactors and fusion breakthroughs and a role in fighting climate change, it can power a safer and better world. By tackling safety, costs, and risks, we can unlock its true power for further generations. And that's our time. Thank you for listening.